Now today we are going to study polynomials as per class 9 NCERT syllabus, and uh, to begin with we should recall our understanding of algebraic expression, because polynomial is a kind of algebraic expression only. We know about algebraic expressions, and whatever we have learned about algebraic expressions are useful here, and that will help us in understanding this, because this polynomial is a kind of algebraic expression only. So it's not a, it is a new thing, but it's further learning of algebraic expression to know this polynomial. So we know about it. Now let us see these examples. This is 2x, this is 3x, this is minus x, this is minus 1 by 2 x. We know that from our earlier study and knowledge and understanding of algebraic expressions, that algebraic expression can be expressed as symbols. These symbols are x, y, z, etc. And these symbols can take any value, and these symbols are called variables. Here it is 2x, x is a variable, 2 is a constant. Here 3x, x is a variable, 3 is a constant, minus x, minus 1 and x. So this minus 1 is a constant, x is a variable, minus 1 by 2x, minus 1 by 2 constant, x is a variable. So in such kind of algebraic expressions, single term can be written as ax, where a is a constant. A is called constant because it has a fixed value for any problem, and x is a variable. X is a variable which takes any real value. And we have seen, while solving problems using algebraic expressions, that in case of this is a case of a square having side of 3 units. A square has got all the side equal and all sides are 3 units. When we say what is the perimeter of this square, perimeter is sum of sides. So this has got 4 sides, so 4 into 3. This is the perimeter of a square, can be expressed as 3 plus 3 plus 3, 4 into 3. So when the side becomes 5, this is 4 into 5. When the side becomes 6, this is 4 into 6. So the perimeter varies whenever the side varies. This is varying, but this 4 is fixed. For this perimeter, we can write algebraic expression 4x. 4x algebraic expression can express perimeter of a square, where 4 is a constant and x is a variable. X is the side of the square, and with different sizes or different value for the side, we will have different value of perimeter, but this constant 4 will remain same in all the problems of perimeter. So this gives a clear picture about what is constant and what is variable. Now let us see few more cases of algebraic expression. 2x, x square plus 2x, x cube minus x square plus 4x plus 7, 3y square plus 5y, minus x cube plus 4x square plus 7x plus 2. In all such cases, we see here variable is x, here also variable is x, here also variable is x, here variable is y, here variable is x. Now let us see what is the exponent of this variable x or y in these algebraic expressions. Here the exponent is 1 because it is x, so anything in its original form has got power 1, so it has got power of exponent 1. it has got exponent 2 because it is x square. In this term 2x, x has got exponent 1. In this term x cube, the variable x has got exponent 3. Here the exponent is 2. Here the exponent is 1. Here the exponent is 2. Here the exponent is 1. Here the exponent of x is 3. Here exponent of x is 2. Here exponent of x is 1. In all such cases, we see the exponents are 1, 2, 3, etc. And it is important for us to now understand this, that whenever the exponent of variable is a whole number, then that algebraic expression becomes polynomial. So wherever we see an algebraic expression and find the exponent of variable as whole number, when exponent of variable becomes a whole number, then it's a polynomial. So what is polynomial? First we know this is algebraic expression only. Now the other thing, exponent of variable is a whole number. If exponent of variable is whole number, then we will calling the algebraic expression as polynomial. Now it is also, although we know about it, but let us recall quickly. This is a single term 2x. Here x square plus 2x. There are two terms. Here x cube minus x square plus 4x plus 7. 4 term. Here 3y square plus 5y. 2 term. Here minus x cube plus 4x square plus 7x plus 2. These are 4 terms. So we see that these individually, these x square 2x, 2x, x cube minus x square 4x, 7, 3y square 5y minus x cube plus 4x square plus 7x plus 2. Individually, these are called terms of polynomial. These are terms which this thing we know, but I just recall it that these are terms. X square is a term, 2x is a term. X cube is a term, x square is a term, 4x is a term, 7 is a term, 3y square is a term, 5y is a term, minus x cube is a term, 4x square is a term, 7x is a term, 2 is a term. Now, when we see term, we see that term is a product of its factor. 2x is what? 2 into x. So it's product of its factor. Again, let us see some other term. Let us see this x square. What is x square? 1 into x square. Let us see any other term. Minus x square. This is minus 1 into x square. Let us write down what term we are mentioning. Otherwise, okay. Let us see some other term. 4x square. So what is 4x square? 4 into x square is 4x square. So we see that similarly we can think about other terms also. So all these terms are product of its factors. We see all the terms are product of its factors. And in this there is a numerical value and then variable. Numerical value is multiplied with a number. These numerical values, in the factors of the term, the numerical value, this numerical value is called coefficient of term. Coefficient are called coefficient. Suppose sometimes we are asked what is the coefficient of x square here. So x square, when we will be asked to ask this question, we will be asked for a particular algebraic expression or polynomial. If we are asked to say the coefficient of x square in this polynomial, then x square is minus x square. That means minus 1 into x square. So the coefficient here, coefficient of x square in this polynomial is minus 1. What is coefficient of x cube in this polynomial? X cube is minus 1 into x cube. So the coefficient of x cube here is minus 1. What is the coefficient of 4x of x in this? X is multiplied with 4. So the coefficient here is 4. Similarly, we can think about some other problems also, and this applies to all polynomials, and this is for us to understand fully well, so that we apply it wherever we come across such problems. Now let us come. Now we understood that algebraic expression having a variable and variable having exponent as whole number are called polynomials. Now let us see these three examples to understand our understanding of polynomials. X plus 1 by x. This can be written as x plus x to the power minus 1. This we know. This can be written as x to the power 1 by 2 plus 3. This is a square root of 2 plus 3. This can be written as x to the power 1 by 2 plus 3. This is cube root of y. So this can be written as y to the power 1 by 3 plus y square. Here we see that exponent of variable x is minus 1 here. Here the exponent is 1 by 2. Here the exponent is 1 by 3, which are not the whole number. So these are not polynomials. These are not polynomials because the exponent of variable is not a whole number. Now another thing for us to know is that this let us recall quickly our earlier understanding. The polynomial can be like this, 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 etc. The polynomial can have one term, polynomial can have two term, polynomial can have three term, or so on and so forth. When the polynomial has got only one term, we will call it monomial. We will be calling it monomials. This we have understood in our earlier classes, but we are recalling it. When the polynomial has got two term, then it is binomial. Binomial. When it has got three term, it is trinomial. So this is a terminology which we have understood in our previous class. Then there is another thing for us to know, which is also important for us. Let us see an example of x square plus 4x plus 4. This is a polynomial because the variable x has got exponent 2 and 1 here. Now when we are asked to say the coefficient, we can very well say the coefficient of x square is 1, coefficient of x is 4. When sometimes we think about what is this 4. So this 4 is 4 into x to the power 0, because anything raised to the power 0 becomes 1. So 4 is a coefficient of x to the power 0. So this, then again this x square itself is a polynomial, 4x is a polynomial, likewise 4 is also a polynomial. This 1, 2, 3, 4, etc. these numbers, these are also polynomials, and these are called constant polynomial. Constant polynomial. And this constant polynomial can be written as, any constant polynomial is written as, one can be written as 1 into x to the power 0, 2 can be written as 2 into x to the power 0, 3 can be written as 3 into x to the power 0, 4 can be written as 4 into x to the power 0. Here the variable has got the exponent as 0, which is a whole number, so these are the polynomials. And this, in this case, these are called, these numbers are called constant polynomials. Again, you may think about 0. 0 is although a constant polynomial, but it is separately defined as 0 polynomial. It is 0 polynomial, and this is not defined. So this is also important for us to understand that 0, although a constant polynomial, but it is separately called 0 polynomial and it is not defined. So this thing also we should know. Now let us understand the standard form or the denotation by which we denote polynomials. Polynomials are written as polynomial p in variable x, 2x square plus 5x minus 3. If this is a algebraic expression which is a polynomial, then we can write it as polynomial p. Artificially we have denoted it by p, and since the variable is x, we say polynomial p in variable x this. This is polynomial q in variable x this. This is polynomial r in variable y this. This is polynomial s in variable u, like this. Now here also we see, then we can also make out that t and z 2z. This is polynomial t in variable z 2z. So now you see here it has got only one term, it has got two term, it has got three term, it has got four term, it has got three term. So terms we know. Wherever we are asked to say coefficient, we know the numerical value of the factor of the term is called coefficient. Now again, this new term which is coming to for us to understand is degree, which also we have studied earlier, but let us recall that. Here the highest power of variable is 2. In polynomial p, the highest power is 2. In polynomial q, the highest power of variable x is 3. In polynomial r, the highest power of variable y is 3. In polynomial s, the highest power of variable u is 5. In polynomial t, the highest power of variable z is 1. So these powers, based on the powers of the variable, we also define a term degree. Whenever the highest power of a variable is 1, like this, we will call the degree of this polynomial as 1. If the highest power here is 5, then we will be called the degree of this polynomial as 5. Here we will call degree of this polynomial 3. Here the highest power is 3, so we will call degree of polynomial 3. In here the highest power is 2, so we will call the degree of this polynomial as 2. So what is degree? Degree of a polynomial is the highest power of variable in any term. In any term, highest power of the variable is called degree of that polynomial. And this terminology we know and understand, but we should remember. Now we have discussed that 2 is also a polynomial because 2 is 2 into x to the power 0. So whenever this is 1, 2, 3, 4, 5, if we talk about these constant polynomials, in this case these are multiplied with x to the power 0. So degree of a constant polynomial is 0. Degree of a constant polynomial is 0. And now let us come to the now let us apply our understanding of degree here to understand our understanding and make sure that we remember it in our mind. So this is a polynomial x to the power 5 minus x to the power 4 plus 3. Let us see this polynomial. Here the highest power is 5. Highest power of variable is 5. So the degree here is 5. Degree here is, degree of this polynomial is 5. Here the highest power of y, which is a variable here, is 8. So degree is 8. In case of this constant polynomial, we have understood that this is 2 into x to the power 0. So this degree of this constant polynomial is 0. This we have understood. Then again we see degree 5, degree 8, degree can be more. So based on this, a natural question which comes in our mind is how many terms it can have. So it can have any finite number of terms. The polynomial can have any finite number of terms. That we know about the degree of a polynomial, we have understood it that degree of a polynomial is the highest power of the variable. So now that we know this, now let us see a few trends. This is the standard way of writing polynomial. This is polynomial p in variable x, 4x plus 5. This is polynomial q in variable y, 2y. This is polynomial r in variable t plus under root 2. This is polynomial s in variable u, 3 minus u. In all such cases, the highest power of variable x, y, t, u is 1. So the degree of all these 4 is 1. Degree is 1 because the highest power is 1. And when the degree is 1, then in that case, such kind of polynomials are called linear polynomials. Such kind of polynomials are called linear polynomials. This is example of linear polynomial where the degree is 1. In such cases, we see that this variable x is multiplied with a constant, then another constant is added. Here, variable y is multiplied with a constant 2 and then nothing is added. So let us say that it is 0 is added. Here t is t plus under root 2. So again here variable t is multiplied with 1, then under root 2 is added. Here variable u is multiplied with minus 1 and then 3 is added. So in all such cases, we see a definite pattern where a variable is multiplied with a constant and then another constant is added. So these linear polynomials are of this pattern, ax plus b, where a and b, this a and b are constants, x is variable and a is not equal to 0, because when a becomes 0, this becomes b, which is a constant, and then it becomes a constant polynomial. Then it is not a linear polynomial. So for linear polynomial, degrees of the polynomial should be 1, and this polynomial has the standard form of ax plus b, where a is not equal to 0. From this we can easily make out that in case of linear polynomial, the polynomial can have two term, maximum two term. It can have one term also like this, where it has got only one term, but it can have maximum two term. Now, having understood linear polynomial, now let us see these polynomials. 2x square plus 5, 5x square plus 3x plus 5, x square plus 2y 5x, 5 minus y square, 4y plus 5y square, 6 minus y square. So, in all these polynomials, the highest power of variable x is 2. Here the highest power of variable x is 2. Here the highest power of variable x is 2. Here the highest power of variable y is 2. Here the highest power of variable y is 2. Here the highest power of variable y is 2. In all such cases, the highest power of variable is 2, and when the highest power of variable is 2, it's a polynomial of degree 2. And when it is polynomial of degree 2, then it is called quadratic. Quadratic polynomial. When the degree becomes 2, it is quadratic polynomial. And when it is a quadratic polynomial, from the patterns of these polynomials, we can, this quadratic polynomial is of type ax square plus bx plus c, where a, b, c are constants and x is a variable and a should not be equal to 0. Because when a becomes 0, then it becomes linear polynomial. So, a quadratic polynomial can be expressed as ax square plus bx plus c, where a, b, c are constant, x is variable and a is not equal to 0. And we are also able to understand from this that a quadratic polynomial can have a maximum 3 term. It can have one term also, it can have two term also, but it can have maximum 3 term. So this is also important learning for all of us to understand. Let us see these polynomials. 4x cube, 2x cube plus 1, 5x cube plus x square, 6x cube plus x minus x, 2x cube plus 4x square plus 6x plus 7. In all these polynomials, the highest power of variable is 3 here, 3 here, 3 here, 3 here and 3 here. So, in all these polynomials, the highest power of variable is 3. So, the degree of the polynomial is 3. And when the degree becomes 3, it is called cubic polynomial. So, this is another kind, the third kind, cubic polynomial. And in cubic polynomial, we can express cubic polynomial as ax cube plus bx square plus cx plus d. It can be expressed like ax cube plus bx square plus cx plus d, where a, b, c, d are constants and x is variable, and a should not be equal to 0, because when a becomes 0, it becomes a quadratic polynomial. So, this is the standard form, standard way of writing this cubic polynomial. And now let us come to, having understood the polynomials of degree 1, 2 and 3, a general thing which we can write about a polynomial in one variable as sub an xn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2 plus so on and so forth, and this is a1x plus a0. So this is a general way of writing, general way of expressing a polynomial in one variable of degree n, an xn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2 dash dash a1x plus a0. This is polynomial in variable x of degree n, and in this an minus 1, a1, a0 are constants and x is variable, and an should not be equal to 0, because when an becomes 0 then it's not having degree n. If it is having degree n, then this an should not be equal to 0. So this is all about our learning of polynomials at this 2.1 level, and then we will go further in our next videos.